Okay, we are going to learn how to graph quadratic equations without using the y equals feature on your calculator. So the first thing that we want to do is find our axis of symmetry, and we're going to use the equation negative b divided by 2a. So I need to find my a value and my b value of that equation, and if you want to, you can go ahead and write down the c, so the c value as well. A is the imaginary 1 in front of your x squared, b is the negative 8 in front of the x, and c is your constant, that's positive 7. So if I'm plugging those values into my equation, it goes negative my b value, which was negative 8, divided by 2 times my a value, 1. And if I simplify this, double negatives makes that positive 8 on the top, 2 times 1 on the bottom is 2, and I've got my value of 4. So that means that we have an axis of symmetry at x is equal to positive 4, and I'm going to go ahead and draw in a dashed vertical line to represent the axis of symmetry, because we are going to be using this axis to help us draw the rest of the quadratic. So I'd say axis of symmetry is x equals 4. Now, the vertex is on your axis of symmetry, which means that it has the same x value. So we're going to take that x value of equal to 4 and take the original problem, which was y is equal to x squared minus 8x plus 7. And all we've got to do is take that x value and plug it in to find our y value of the vertex. So 4 squared minus 8 times 4 plus 7. And if I need to, I can type that into my calculator just like it looks, and I end up with negative 9. So that means y is equal to negative 9, and we've got a vertex point at positive 4 comma negative 9. X value, then y value. And I can go ahead and plot that vertex point on my parabola, or on my axis of symmetry. Now for step number 3, we need to factor the quadratic equation to find the x-intercepts. So guys, when you are crossing the x-axis, that means y equals 0. So the original problem was y is equal to x squared minus 8x plus 7. We are looking for where the y value is equal to 0, and we are going to have to factor this trinomial. Now it doesn't have a number in front of the x squared, which means we can jump straight to putting our x's in the parentheses. I'm going to list the factors of a positive 7, which could be both positive or both negative, but the ones that are going to add to give me negative 8 are negative 1 and negative 7. Now, the thing that we learned is that when we are multiplying two things together and our answer is 0, then that means one of those or both of those parentheses have to equal 0 themselves. And all you are doing at this point is just a one-step problem. On this one, I would add 1 and get x is equal to positive 1. On the other one, I add 7 to both sides, and I got x is equal to 7. Now, these are my x-intercepts, so let's go ahead and plot those points at 1 and 7. And notice that they are 1, 2, 3 units to the right and 1, 2, 3 units to the left of my axis of symmetry. So we've got the first few points of our quadratic. Now, the real question is, how do we find the rest of the points? Now, here's what I would do. We've already got a point at 1, we have a 2, and right here would be a 3. Let's go ahead and use those x values of 2 and 3, and possibly even an x value of 0 so that we can find our y-intercept. So I'm going to be plugging in several different x values into the problem to find some more points. So I'm going to take the original problem, which was y is equal to x squared minus 8x plus 7, and in the first one, I'm going to plug in x equals 0. Okay, so let's plug in x equals 0. That would give me the equation. Y is equal to 0 squared minus 8 times 0 plus 7. And if you type all of that into your calculator, you've got the answer, positive 7. So that means when my x value is 0, my y value is 7, we've got a point at 0, 7 of our quadratic. So if I plot that point, that one's on my y-intercept, and I've got another point right there. So I used x equals 0, so that's one point. We already have a point at 1 something, so let's try plugging in 2. So this time I'm going to do x equals positive 2. So y is equal to 2 squared minus 8 times 2 plus 7. I'm going to type that into my calculator to see what it gets me. Now I type that in, I end up with negative 5. So that means my y value is negative 5, and we've got the ordered pair, positive 2, comma, negative 5. Okay, so there's another point. Let's go ahead and plot that one. 2, negative 5. Looks like it would be right there. Okay? So we've got a point at 0 something, 1 something, 2 something. We need a point at 3. So I'm going to go ahead now and plug in a positive 3. So x equals 3 into that same original equation. So y is equal to 3 squared minus 8 times 3 plus 7. So let's go ahead and type that into the calculator. And when I hit enter, that gives me negative 8. So y equals negative 8. That means we've got an ordered pair of x equals 3, y equals negative 8. So let's go ahead and plot that point. So right 3 and down 8 is right here. Now, instead of plugging in some more numbers, what we can actually do is use our axis of symmetry and reflect the other points across the x-axis. So here's what I'm saying. We've got our vertex right here. If you go up from that, we've got a point that's 1 to the left of the axis of symmetry. So if there's a point that's 1 to the left, there's a point that's also 1 to the right. So I can just kind of skip over that and reflect it. For my next point, it's 1, 2 to the left, so I'm going to put a point 1, 2 to the right. Up here on my my x-axis, we've already got the 2 points, so let's go ahead and go up here and do one more. That point was 1, 2, 3, 4 to the left, so I'm going to go 1, 2, 3, 4 to the right. Now I've got my quadratic, and I'm going to connect my points with a curved line. It's kind of hard to do that. Yours might not be as straight, but that's all right.